Now, Mendeleev's periodic classification of elements is very authentic as it was based upon the fundamental property of the atom, that is its mass, and not only the atomic mass but also chemical properties. At the time of Mendeleev, 63 elements were known, and he arranged all these 63 elements in the increasing order of atomic masses. Not only this, he reacted these 63 elements with two elements, hydrogen and oxygen, right? And he obtained their oxides and hydrides. If you look at table 5.4, you can see that he has arrange the 63 elements in a table where there are 8 vertical columns called groups and there are 6 horizontal rows called periods. Now you see, he has also mentioned oxide and hydride. Okay. Then in group 1, he has written R2O. Okay. Here R refers to any element of group 1. Then in group 2 he has written RO and RH2. Okay. Here again R refers to any element of that group. So when you look at this table 5.4, in each group R can be any element of that group, right? But the other element will be either oxygen or hydrogen. So this made our study very easy, that if we know the formula of oxide of one element of that group, let us say that the formula of lithium is Li2O, then it will be Na2O for sodium and K2O for potassium, right? Now you see, he said that the properties of the elements are periodic function of their atomic masses. And he started arranging these elements in the increasing order of atomic mass. Now what happened? What are his achievements? And what are the achievements which helped to give authenticity to his classification was, number 1, there were anomalous pairs. Now what are anomalous pairs? Students, if you refer to group 3-4, period 3, you will find that in group 3, period 3, there is aluminium. Group 4, period 3, there is silicon. Okay? Just look at this in your book. You will find atomic mass of aluminium is greater than atomic mass of silicon, right? Similarly, if we look into group 5, vanadium, group 6, chromium, both in period 4, then atomic mass of vanadium is greater than chromium, atomic mass of cobalt greater than nickel, and atomic mass of tellurium greater than iodine. Now this was an anomaly, because he was saying that I am arranging elements in the increasing order of atomic mass. So he was contradicting his own law, but he was very bold enough to ignore the atomic mass. But when he saw that the compounds of aluminium with oxygen and hydrogen resemble to the elements of group 3 and not group 4, so although this was having higher atomic mass, he kept it in group 3. Similarly, he kept vanadium in group 5, cobalt in group 8, right, and tellurium in group 6. Fine. So this was anomalous pairs. The other bold thing he did was he left some gaps in his periodic table, and he boldly predicted that there will be some elements which will be discovered and those elements will fit into these gaps. He named those elements as Aka boron, Aka aluminium and Aka silicon, right? And when he predicted their place in the periodic table, he also predicted the formulae of their oxides as well as hydrides, right? And when gallium was discovered, it was just falling into the place which was left vacant by Mendeleev as Aka aluminium. So this gave more authenticity to the Mendeleev's periodic classification, right? So this was, the achievement of the Mendeleev. Now what happened that when, isotopes were discovered, okay, now you see he gave one position to carbon, one position to chlorine on the basis of atomic mass of carbon, which was taken as 12. Then chlorine atomic mass 35. But when the isotopes were discovered that carbon can have mass 12, mass 14, chlorine with 35, 37, he did not have any answer how to adjust these isotopes in his periodic table. So this was a limitation, right? The second limitation, he could not explain that why is hydrogen kept in group 1. Although it behaves like, halogens, it has diatomic molecule. So there was a controversy related to the position of hydrogen in the periodic table. The other controversial thing about his classification was that he said that my law is based on the arranging the elements in ascending order of their atomic masses, but in anomalous pairs, he was keeping the element with higher atomic mass before the element with lower atomic mass. So these were the anomalies, right? And he could not explain that why hydrogen should be kept only in group 1. So due to these anomalies, due to the discovery of isotopes, his law was, discarded, right? Now the achievements are, number 1, anomalous pairs. He based his law not only on the atomic mass but also on its chemical properties. Then he left some gaps, and then the inert gases, noble gases, which were discovered afterwards because they were very less reactive, so nobody knew. But when these gases were discovered, these were adjusted in his table without any fuss. But because of the limitations, this law was discarded when atomic number was found, right? So when Henry Moseley talked about atomic number, which was more fundamental property, then this law was no more applicable. A new law for classification, that is modern periodic law, was designed, and we will be discussing that in the next video. Thank you so much. God bless.